Hello and welcome to the channel. My name is Samuel Barless. Here we talk about networking and cybersecurity. I want to start a new series. I'm going to call it CCNA By Objective. Now the reason I'm going to do this is instead of focusing on kind of the NetCAD structure that I typically teach from, I want to go directly from the exam blueprint, which is what you're seeing on your screen here. I want to go by the exam blueprint and kind of just give an overview. Now this is not meant to be exhaustive. This is not meant to be a replacement for CCNA studies. It's really meant for a supplemental to CCNA studies to help you, one, integrate into real world, two, hopefully grasp it a little more instead of just knowing what you need to know to pass a test, but actually grasping and understanding the holistic approach to networking, because understanding switches is great, understanding routers is great, understanding firewalls is great, APs, it's great. It's all right here we're going to talk about today. But how do those things work together? How do they cohesively all create our network that we are using today? So with that, again, this is not meant to be exhaustive. This is really just meant to supplement other CCNA material, or maybe if you're not studying for the CCNA, you're just trying to learn more about networking. Hopefully this will give you some real world kind of examples and sort of a starting point to get in the real world of networking. Little background on me just before we start here. I am CCNA certified. I have been teaching CCNA for a number of years now. I've been in the networking industry about a decade, and I'm currently in a cybersecurity role for my day job. So just jumping straight into it, hopefully this will only take a few minutes here. We're going to talk about routers. So when we talk about routers, you'll typically see them depicted as a circle with some arrows. This is how we typically display a router in Cisco documentation, and generally in the industry, a lot of people will refer to a router in documentation with this little image here. Now routers, the way I would kind of define them is they break up our layer 2 domains. Another word for that would be our broadcast domains. So what we're doing, when I like to draw routers in a network diagram, I like to kind of segment them off. So for example, maybe we have a switch over here and a switch over here, connect down to these other networks, right? So we'll call this network 1, we'll call this network 2, maybe this will be 10.1.x, and I'm just going to use these as a quick example, 2.x. This is not meant to be real world. Just to give you a quick example, I like to go ahead and kind of like split up the router and go, hey, well, maybe we're going to go right here, and we'll say that this side is connected to network 1 and this side is connected to network 2. I find that helps me kind of visualize the difference here, and helps kind of get students to kind of understand that we're breaking up these broadcast domains with a router. And so when you try to send a broadcast, maybe you're looking to get an IP address from DHCP or something like that, that broadcast is not going to traverse the router. So we're breaking up networks, and we're actually routing. That's where the term router comes from. We're routing between those different networks. Now, key functionality of routers is by default, generally speaking, and definitely in Cisco world, routers forward. This is important because when we start talking about firewalls in the Cisco world, by default, firewalls block. They don't forward. And that's very important when we start getting into kind of more security conversation. Now routers can serve lots of different functions. One of the things you'll typically see in a home network is you'll have a combo device that's going to be doing a lot more and implement a lot of these different devices we're going to be talking about into one device. But a router can do things like network address translation. This is extremely important for IPv4 because we ran out of addresses. We're all out. So when we start talking about having an edge device before we get to our ISP, we typically do NAT so that we NAT out and we only use one IP address for our entire business, maybe our entire home. In some cases, some decent-sized businesses can use one IP. Now, in the enterprise environments that I've been part of, generally speaking, you have multiple IP addresses that you can NAT out on. But for the sake of this conversation, we don't need to get into that nitty-gritty detail there. So we perform things like NAT. Again, we split up networks. We can perform some security with stuff like ACLs, right? So we can split up those networks and not allow certain traffic to go between them and stuff like that if we want. But generally, our routers are going to do routing functions. So when we talk about routing functions and routing devices, we have other devices that can do that, and we'll talk about those when we get to those devices. There's all kinds of routing devices that can do routing. Typically, routers are going to do routing the best. Now, the reason is we can do routing in ASICs. We can do routing in the hardware, and so we don't necessarily have software and generalized CPUs to slow us down when we're talking about routers. Now, again, they serve a specific function, and so they can do it well. So, routers may implement technologies like static routing, maybe dynamic routing, and that might be in the form of RIP, which is generally old. Usually if we use RIP, we'll use version 2, OSPF, which is probably my favorite here, BGP, which could be internal or external, which I won't get into that detail, but just know that there is an internal version. Generally it's external, but there is an internal BGP, and EIGRP if you are a Cisco shop. Generally speaking, though, I've used a whole lot of OSPF in a past life at a previous employer, and I really like the way that OSPF works and the way we can kind of break up our different domains there. BGP is pretty cool as well. If you start getting into the nitty-gritty, it can get super duper complex. Probably not going to study it a whole lot for your CCNA. Just know it exists. There's an internal, there's an external version, and it's a routing protocol, and that's pretty much all you'll need to know there. I think that's really everything I want to talk about when we're talking about routers. So I'm going to go ahead and start erasing this. Power of technology, you can always pause the video, roll it back, run it slower if for any reason you want any of this content here. Next thing on our device, I think, are layer 2 and layer 3 switches. So layer 2 switches are going to break up our collision domain. So this is something that we don't have to deal with a whole lot anymore because we're not dealing with hubs all the time. But it was something that was a problem at some point. Essentially, our layer 2 switches, every port is going to be its own collision domain because we're not running hubs anymore. Hubs were all in one collision domain, the whole hub was. But switches, we're going to break up that collision domain. This is huge in terms of efficiency in our network. It's very, very important that we do that. Layer 3 switches also do that, but they can. Now this is only if you configure it this way. This is not by default. We can configure them with layer 3 features. And I'm losing my words, break up broadcast domains. Now we can also do routing functions. And that's what we mean by layer 3, a layer 3 switch, or L3 switch for short. So that's really what that means. We can do routing functions on a switch. So layer 3 switches are a little more expensive than layer 2 switches, and they typically have maybe other features as well that you may not see in all layer 2 switches. Typically layer 3 switches, if they have these layer 3 capabilities, they're going to have other kind of more advanced feature sets. Maybe we'll be dealing with some more complex quality of service and some other things as well. But depending on your layer 3 switch, some of them may only support static routing, some may only support RIP and static routing, and others may support a plethora of options. Depending on the vendor that you're using and the model that you're using, this can vary widely across the industry. So it's something I really want you to look out for. If you're purchasing a layer 3 switch, make sure it supports a modern routing protocol like OSPF. Even if you don't plan on using it today, if you're going to go ahead and shell out the cash for something layer 3, let's really make sure that we're planning for the future. That was something really disappointing for me when I went into an environment and I went to go implement routing and found out that a lot of our switches didn't actually support proper routing, and we had to do some kind of loopholes and funny stuff that we wouldn't get into detail of until we get to the CCNP, because it starts getting really complicated when we start talking about route redistribution and some of the other things we can do with our routing protocols. That's more complicated. So other than that, layer 2 and layer 3 switches, they kind of connect everything together. That's the first point where typically our end devices would connect to our network. And we'll talk about the 3-tier architecture in a later video. I do have some videos if you're in my course on those, but I will talk about those in a later video in this series as well, talking about the different layers and how those interact and what kind of switch would fit in what layer and how those all switches have different roles. But for the sake of this video, I'm not going to go into that. I'm just going to go super overview here. It's really just the role and the function of network components. That's the goal of this particular section here. We just want to explain these. Next gen firewall and IPS. So next generation firewall, NGFW and IPS. So the next generation firewall is a really great evolution of firewalls that we have gotten. In the past, firewalls used to, right? So traditional firewalls, I'll put trad firewall, are IP and port blocking. Now this is good. We want to do IP and port blocking. That's a good thing. We need that in our network for it to have some layer of security, some level of security. But next generation firewalls came in and said, we do all that, yes, absolutely, but we're going to add other things. So our traditional firewall may or may not be stateful. Today, typically, it would be a stateful firewall. I'm going to put that in there. And that means a very important thing when we start talking about ACLs, ACLs are not stateful. So that means if you have a ping going out, right, and we'll put a little router in here just for the example. So we'll do ICMP going out, and then you have a reply, right? So if you were to write an ACL for this, you would have to write ACL1 going this way, and ACL2 going that way. So that way we can allow the sent traffic and the return traffic. Now, this is very granular, but it can be a huge pain in the rear. So really, when we're talking about stateful firewalls, we're able to take that ICMP packet, we're able to put it into a state database, and we're able to say, hey, this reply is a reply to this packet that we sent. So we know that it is a reply to a legitimate piece of traffic. The other thing is we can't spoof a reply and just come straight in because it's not in that state database. This is very, very important stuff for a firewall. Next generation firewall, really what we got there is these UTM features. These are awesome, super duper important. If you're talking about really having proper security in your network, these UTM features are super important. The other thing we want to talk about with UTM features, before we get into the details of what they are and what they do, is threat intelligence. So you'll hear me talk about threat intelligence all the time, and really it's because threat intelligence is super duper important. So before we get any further here, I actually want to go ahead and pop this screen up and tell you that I may say some things in this video that my employer does not agree with. I may say things that past employers, present employers, future employers don't agree with. Opinions in this video are my opinions and may or may not reflect those opinions. I want to give you a nice disclaimer. I forgot to do at the beginning of the video. Back over here, UTM features. UTM features are only as good as the threat intelligence that they have. So I'm going to put TI over here. Threat intelligence is super important. So UTM features, maybe stuff like web filtering, maybe stuff like AV. Now this does not replace endpoint AV. I can tell you how many times I've heard people go, oh, well, I've got this new firewall with antivirus protection. I can get rid of my antivirus, right? No, because your firewall is not going to see 100% of everything all the time. Is it? If you're doing deep packet inspection, your machines never leave the network, maybe. If you're not, if you, some things don't work with deep packet inspection. So for example, Dropbox is a very common example. Dropbox will give you all kinds of issues and won't connect if you try to do deep packet inspection. That's where that AV on the machine comes in handy for stuff like that, where you're not going to be able to do that DPI on your firewall. Other things we may have, IPS. That is a UTM feature. That's specifically mentioned here, intrusion prevention system. So an IPS, obviously you have to have an IDS, an intrusion detection system, to detect it before you prevent it. But we do have that IPS system there. Again, I want to refer you back. The IPS system is only as good as the threat intelligence that we have. So we want to make sure that threat intelligence going into our IPS is good. Now there's a plethora of other features here that we could talk about. Depending on your vendor, they may vary a little bit. Some of them may get very deep and complicated. Some of them may be pretty surface level. Some of them may have lots and lots of settings. Some of them may have very few. But I just want you to be aware of these kind of like core UTM features here: web filtering, antivirus, and IPS. And if you have questions or anything about those UTM features, you can always refer to whatever vendor you're working with. If you don't have a vendor you're working with, Cisco is something that is commonly taught, so you may be able to find instructional videos on that. There's a lot of other good vendors out there that make some pretty strong UTM firewalls that you can go look up information on. I really like companies that put out docs on the open web without having to put like a support login or anything, because one, that helps us learn. Two, it's really transparent. And three, it makes my life easier as a customer because if I'm going and troubleshooting something, I don't have to go and find my support credentials and go log in and everything just to find some documentation. So you may find that a lot of companies that make these UTM-enabled next-generation firewalls have those documents available on the public internet for you to just go look at. Check out some data sheets, check out some information on those, maybe some administrative guides, stuff like that, all around the industry. I think that's really all I want to talk about here. The other thing I want to talk about with IPS, just real quick as I'm erasing this, is that IPS is just basically looking for the signatures of common attacks, maybe like a SQL injection or something like that. That's common in your network. Close that out. Next thing here we have is access points, right? So commonly referred to as WAPs, wireless access points. No, I'm not talking about that nasty song. I'm talking about access points. So these are just going to be typically PoE powered, power over Ethernet. So we're going to power them typically from a power over Ethernet switch or maybe a injector. And then maybe they'll be circular, maybe they'll be rectangular, depending on the vendor you have. And basically they will emit a Wi-Fi signal so you can connect things like, maybe your little cell phone, maybe a tablet, maybe a laptop. I'm going to draw a poor excuse for a laptop there. And you can connect all these devices wirelessly. Now, these last few things we've talked about, routers, switches, firewalls, access points, they're typically all bundled together into one device for your home. And so it kind of makes it confusing for a lot of people starting out because it's all one device. Now, that device can serve multiple functions. In fact, Cisco has routers that have switching modules in them that you can add, so your router can be a switch. And there's other things like wireless modules you can put in and other stuff. Other vendors have similar stuff where you can buy a combo unit that has wireless in it as well as firewall features and other things. So it really just depends on your environment. Usually those are great for smaller environments, and once you start getting to a larger environment, you don't want these devices that are all together for several reasons. One, you want resiliency, so you want to make sure you're not heavily reliant on one device or a very few amount of devices. And two, you want really good scalability, and it kind of makes it difficult to scale usually with those kind of solutions. But at a house, you just typically have one, maybe a mesh system, a few different access points, and it's usually pretty fine. So, of course, you can have the classic 2.4 gigahertz Wi-Fi. You can have 5 gigahertz Wi-Fi. Now we're talking about 6 gigahertz Wi-Fi as well with Wi-Fi 6E. So you have all those different options. A lot of these enterprise are also going to implement stuff like Bluetooth and maybe some Z-Wave or Zigbee as well for the kind of smart home technology, which is now becoming more and more prevalent in business as well. And so one of the large wireless manufacturers that I was working with in the past, they started implementing Bluetooth, Z-Wave, and Zigbee antennas when they started doing Wi-Fi 6 stuff. And it was pretty interesting to see all the kind of like analytics we could pull from those devices, being able to see all that traffic going on, doing user tracking with Bluetooth so we could see where Bluetooth devices were roaming to. And so we could see maybe where some coverage gaps were, and we could essentially use our controller to analyze the map and go, okay, well, over here we're having some issues. Those are some pretty advanced Wi-Fi features that, in fact, probably most businesses don't need, but they are out there. They do exist if your Wi-Fi is mission critical. That may be something that's important for you to consider when you're looking at wireless APs. But for a lot of businesses, wireless is more of a commodity. It's more of a convenience than it is really mission critical. And so cost may be a humongous factor there as well. What's the next one? Controllers. So we can talk about different kinds of controllers. Cisco's wireless LAN controller is good. It has a centralized management plane for all of our access points, so we can deploy maybe one SSID to hundreds of access points at one time without having to configure each individual one. Very important when you start scaling. There's some other features, so we can do stuff like CapWap tunnels to tunnel both the management traffic and the actual traffic of our users to that WLC. WLC is for WLC. That's a industry term. Anyway, so we can use these CapWap tunnels. That's a very important technology used for wireless. It's been used for other things as well. I've seen it used for switches and other things. Not as common though. Very, very common in wireless for them to use the CapWap standard for their tunnels. Or we can have what we call like a direct access AP. So you would have like a situation, here's a switch, here's your WLC, and then here you have your AP. And you may drop directly on here, or it may tunnel back. So depending on your use case, your configuration, one may be more optimal than another. Typically, a large campus deployment would have a lot more tunneling. And if we have a distributed, maybe you have a lot of locations, maybe kind of more of the retail side of the world, you would see a lot less tunneling because we don't want that bottleneck to be happening here with the WLC. But depending on your use case, there are options for both in most wireless providers' cases. Some people have WLCs built into other devices. So some vendors may have an all-in-one controller that controls their switches, APs, and other devices. Ubiquiti is pretty famous for this. They have the Dream Machine Pro, I think, that has the camera, recorder. It has Unify Protect, so you can do like door locks. It has the phone system integrated. It has switches, APs. It's all integrated in one box. Now, I'm not trying to recommend Ubiquiti. I'm just saying that it's an example of how this technology is used. Some of Ubiquiti stuff I like. A lot of it I don't. A lot of it has been very disappointing to me. I've used it in production environments before. I've used it in my house. I've used it in businesses before. And sometimes it works and sometimes it doesn't. So if you're really looking for an enterprise grade solution, Ubiquiti is probably not the answer for you. I'm probably going to get some hate from somebody that really loves Ubiquiti. And Ubiquiti makes a lot of good stuff, but not everything Ubiquiti makes is great. I'm just using it again as an example. Some other vendors may implement controllers into other types of devices. I'm thinking of Fortinet implementing their wireless controller and switch controller into their firewalls, which in my opinion is really useful and really awesome. I've used that in production again, similar to Ubiquiti. I've had a much better experience with Fortinet having those firewalls be my controllers for switches and wireless as opposed to Ubiquiti. Jumping on here, what else do we have? Cisco DNA Center, don't let me forget that. So Cisco DNA Center is going to be kind of their automation and analytics platform. So you can do a whole lot of different things with that. I'm not going to get into the details, but basically, again, it's automation and analytics. So you're going to get a whole lot of data going into DNA Center, and you're going to be able to do kind of like controlling features and automation with your switches, your APs, that kind of stuff with Cisco DNA Center. Jumping on from there, endpoints and servers are pretty straightforward. I'm not going to draw pictures and everything. Endpoints are endpoints, or desktops, or phones, or other things like that. Just whatever's end devices connected to the network. And servers are going to be serving some sort of information. Now, they can be application servers, they can be web servers, they can be database servers. Really, typically those are going to be on the back end. Now, really, servers are not necessarily hardware. They're really the function of the device, not necessarily what the device is doing. So keep that in mind. Think of it more like a server at a restaurant. So you're not any different because you're a person, they're a person. They're just taking the role of server. Maybe you go work at another restaurant and you take the role of server, and someone else is the customer. And so, or the endpoint, right? The endpoint is the customer. And so essentially the endpoint tells the server, hey, I would like this website, I would like this application, etc. And then the server responds with the information that is requested. So that's all for this first section here from the CCNA exam blueprint. And join me for the next video as I go over the next topics here. I'll see you next time.